Unit 13, Day 4, Solving Systems of Equations by Elimination, Day 1. Now, so far we've dealt with substitution. Substitution is the one where we have something that is y equals blah, x equals blah, and we can take that chunk and plug it in to the other equation. Now, today, we're giving you a different way to solve these equations, these systems of equations, okay? It's going to be by elimination. Now, as y'all probably guessed, we are going to eliminate something, okay? In order to eliminate something, we have to have what's called a zero pair. These zero pairs occur when we have equal and opposite values for or two equal and opposite coefficients for a variable. Now, that's really just a fancy way of saying zero pair. These right here are all zero pairs. The 6's, the 4's, and we can do this all day on this. We got 3's here, and then the 5's here. So, the zero pairs are what's going to actually cancel. And how we make them cancel is we're going to add the two rows together. So, in this first problem, we're going to add the top row to the bottom row. X plus x is going to be 2x. 5, and then whenever we go to add the y's together, just like I said, they're equal and opposite, they cancel. So, what we're going to be left with is equals 4. The y's just go away entirely. Now, tomorrow we're going to have to deal with what happens if there isn't a zero pair. We have to make a zero pair, all that good stuff. We'll worry about that tomorrow. But today, we're just going to deal with this. So, at this point, you can solve this very simply. Okay, we're going to divide by 2 on both sides, and x equals 2. That part is finished. Now, we can go ahead and start to load up our ordered pair. Now we're going to take our 2, and we're going to plug it back in up here at the top. Okay, so we're going to have 2 plus y equals 5. We're going to minus 2 from both sides, and we are left with y equals 3. And these are just that simple. Now, the next problem, on number 2, as we've already determined, our zero pair is going to be those y's right there. Okay, notice how they are both equal and opposite. They are a plus 1 and a minus 1. When we go to combine those, they'll cancel. Alright, now, if we add our two rows together, we've got 1x plus 2x's, 1 apple plus 2 apples, that's going to be 3x. 11 plus 4 is going to be 15. We divide each side by 3, and x equals 5. Now we're going to take that 5, and we're going to plug it back in for x. Okay? And what we're going to be left with is 5 plus y equals 11. And at that point, it's just simple number crunching, something that y'all should already be very good at. So we're going to minus 5 from both sides, and we got y equals 6. So our final answer is going to be 5, comma, 6. Alright? Number 3. Okay? Just like I mentioned earlier, the zero pair for this one is going to be the 6's. Okay? So we go ahead and we add our two rows together. We're going to have 5 plus 3. That's going to be 8x. Okay? And just like I pointed out earlier, that's a zero pair, so they are going to cancel. And that equals, that's going to equal 16. We divide each side by 8, and we got x equals 2. So now we're going to take this x, and we're going to plug it back in at the top. Okay? And this is where all of y'all's solving skills are going to come in real handy, okay? So we got 5 on the outside of 2. Minus 6y equals negative 32. Alright, now as y'all know, 5 times 2 is 10. Minus 6y equals negative 32. We minus 10 from both sides. And negative 6y equals negative 42. We divide each side by negative 6. And y equals 7. Okay? And we go ahead and throw those into our solution slot. Now, what y'all can do in order to make sure that this works is plug these back into your calculator and make sure that 5 times 2 minus 6 times 7 actually equals negative 32. So that's 5 times 2, which is 10. 7 times 6, which is 42. So 10 minus 42 is, in fact, negative 32. That works. And then you can do the same thing for that second equation. We take 2, plug it in for x, and then we take 7 and plug it in for y. And we have to double check to make sure that that 6 plus 42 does in fact equal 48, and just as luck would have it, it does. So that is a checked answer, okay? Y'all should be able to go back and check all of your answers and verify that they're all right before you even turn in your paper at the end of class. So just make sure that you're doing that, okay? It'll help y'all immensely. Now, number 4, okay? Just as we determined earlier, okay? Our zero pair for this one is going to be the 4 B's, okay? So we know that those are going to cancel on this first go-round. So 3a plus 4a is going to be 7a. We said that the b is going to cancel. We got 2 plus 12, which is going to be 14. We divide each side by 7. We got a equals 2. Now, we can take this 2 and plug it back in up here. And we got 3 on the outside of 2. I'm going to put my 2 there in just a second. 4b equals 2. And then this 2 right here came from the other equation. I'm just writing it in a different color so y'all can see it. So this is our second step, and we're going to go 6 plus 4b equals 2. And this point should be fairly simple for y'all. Y'all have done solving equations before. We're going to minus 6 from both sides. And we got 4b equals negative 4. We divide by 4 on both sides, and we got b equals negative 1. So we can go 2 and negative 1. Make sure to put our parentheses around it. And notation is all taken care of, buttoned up, and ready to go. Now, just so y'all know, we do put these in alpha order. It helps keep everything nice, neat, and organized, and everybody's answers looking the same, okay? At least your correct answers looking the same, okay? So just keep in mind that is how I would like that done, okay? So, moving on here. Number 5, okay? As we determined earlier, our zero pair for this one will be the 3 y's, okay? We've got minus 3y and plus 3y, okay? When we go to combine those, it would be 0y and it would go away, okay? So, when we go to combine this, negative 2x's plus an x is going to be negative 1x, okay? The 3 y's, like I said, are going to cancel, and negative 8 plus 7 is going to be negative 1. We divide each side by negative 1, and x equals 1. Alright, so there's that. We've still got a little ways to go on this. Okay, so we're going to take this and plug it back into the top. And the thing is, you can choose either equation to plug into. Okay, I like positive numbers. I'm going to use that one. So I'm going to go ahead and plug in a 1, okay, plus 3y equals 7. I subtract 1 from both sides, and I got 3y equals 6. I divide each side by 3, and y equals 2. Just like that. Alright? Now, like I said, you can run a check on this real quick. 1 plus 3 times 2, which is 6. 1 plus 6 is 7. Yes, that works. And then you can do it to the other one. It should work. We do negative 2 times 1, which is negative 2. 3 times 2, which is 6. So negative 2 minus 6 is negative 8. So that is a verified answer. Okay, it's always a good idea to check your answers just to make sure you're right. Okay, now, number 6. Okay, we determined earlier that our zero pair for this one is going to be 5x and minus 5x. So when we go to combine this, okay, we wind up with 0x, and those cancel. What we're left with, however, is 3y plus 3y, which is going to be 5y. And then 17 plus 3 is going to be 20. We divide each side by 5, and y equals 4. We're going to take this, plug it back in at the top, and what we're going to be left with is 5x plus 3 times 4 which equals 17. Alright, and then we're going to go ahead and crunch our numbers here. We're going to go 5x plus 12 equals 17. We minus 12 from both sides here. We got 5x equals 5. Divide each side by 5, and we got x equals 1. Alright, so we got 1, and we got 4. Alright? So, the point that I would really like to make on number 6 is it doesn't matter which one that you wind up solving for first. The main objective here is to make sure that you get something to eliminate. Doesn't matter which one. If you wind up getting the x to eliminate, great. If you get the y to eliminate, that's awesome as well. Either way, you've got to get it to where you have just one variable left, okay? One type of variable, okay? Now, moving on to number 7, okay? What do y'all think we would use as our zero pair for this one? Okay, y'all should be thinking y would be good as a zero pair. Alright, so we go ahead and we add our two rows together. And when we do this, we should wind up with negative 3x, which is going to, this is going to cancel, and it is going to equal 9. We divide each side by negative 3. We got x equals negative 3. Alright, so we got negative 3. Alright, and then we're going to take this negative 3 and plug it in back up here. We're going to go negative on the outside of negative 3 minus y equals 8. Alright, now we're going to take this negative and we're going to go across and we're going to take it over the negative 3. So that's going to be 3 minus y equals 8. We minus 3 from both sides and we got negative y equals 5. Divide each side by negative 1. And y equals negative 5. Okay, so negative 5 goes there. And that should be a negative 3, just to make that a little bit clearer. And you can run back through this real quick and go negative 3 plugged in, negative 5 plugged in. And whenever you plug those in here and here, you wind up with 3 plus 5, because don't forget, negative and a negative when multiplied together is a positive. Okay? And you wind up with 3 plus 5, which does in fact equal 8. And then you've got the next one, which is going to be negative 2 and negative 3, which is going to be positive 6 minus 5. 6 minus 5 is 1. And there you have it. Alright? Now, number 8. Okay? With number 8, what do you think we're going to use for our zero pair? If I were to guess, the best thing to use would be those 2's, okay? If you notice, they have the exact same coefficient, but they're opposites, okay? So, we're going to make those be our canceling pair. So, those cancel, and then when we add our 2 rows together, we're left with 6y equals 3 minus 9, which is going to be negative 6. And then we're going to divide each side by 6, and we got y equals negative 1. Alright? So, we know that we're going to have that part. Now we're going to take this negative 1 and plug it back in up here. Alright, so when we do that, we're going to have 2x. Let's do this in a different color. We're going to have 2x, okay, plus negative 1 equals 3. Alright, so that's going to be 2x minus 1 equals 3. We add 1 to both sides. We got 2x equals 4. We divide each side by 2. And x equals 2. Alright? Okay, so continuing our discussion from earlier. Okay, we're still doing elimination. So, on number 9, what do you think would be a good idea for our elimination, our zero pair? You should probably be thinking about these 2's right here, okay? And notice how they have, one's positive, one's negative. It's going to eliminate very nicely, okay? So, we're going to go ahead and we're going to add our 2 rows there. And we're going to have negative 1 plus 4, which is going to be 3x. Our 2 y's are going to cancel. And we're going to be left with equals negative 2 plus negative 7 is going to be negative 9. We divide each side by 3. And we have x equals negative 3. So there we go. We got negative 3 there. Now we're going to take that 3 and we're going to, or that negative 3 rather, and plug it in for x at the top. So we take that negative 3 and we're going to go negative 3 like that. Minus 2y equals negative 2. So we got negative on the outside of negative 3, okay? Don't forget about your negative sign on the outside. It will mess up your calculations and you will have issues, okay? So make sure that you include that. Negative of negative 3 is going to be a positive 3. Minus 2y equals negative 2. Equals negative 2. Alright, now we solve this just like we've solved everything else, okay, step by step. We're going to minus 3 from each side. We're going to have negative 2y equals negative 5. We're going to divide each side by negative 2. Okay, y equals negative, or equals positive 5 halves. Right, now, that seems a little odd. 5 halves. Okay, and I say it looks a little odd because we haven't really come up with many fractions since we started this whole thing. Now, when you wind up with something like that, when your answer winds up looking a little weird, maybe you should run through and make sure that it is correct. Okay, we're going to actually check this one. I'm going to show y'all how. So what we're going to do is we're going to take our solution, which is negative 3, 5 halves, and we're going to plug it back into the original equations. In this case, we're going to take negative 3 and plug it in for x. Make sure that looks like a negative 3. Alright, minus 2 times 5 halves of, okay, and then there's no of to that, sorry, equals negative 2. Alright, so we are going to see if this actually works. Okay, so we're going to go negative of negative 3, which is going to be positive 3, minus 2 times 5 halves, which that's going to be 2 times 5, which is 10. 10 divided by 2 is 5. So minus 5 equals negative 2. Alright? Now that winds up equaling, negative 2. 3 minus 5 is negative 2. You can check that in your calculator if you feel like. So negative 2 equals negative 2. That is a true statement. Therefore, it works in this equation. Now we're going to take our negative 3 and 5 halves and plug it into the other equation. Alright, so whenever we do this, okay, we're going to do negative, let's see, we're going to do 4 times negative 3 plus 2 times 5 halves and that should equal negative 7. Keyword is should. Alright, so let's see if it actually does. Now 4 times negative 3, as we know, is negative 12. Alright, and you can use your calculator if you need to, but 2 times 5 halves, as we've already established, is 5. And negative 12 plus 5 is negative 7. We already know that, and therefore, this is a correct answer. Okay? Anytime that you wind up with something that looks a little fishy, don't be afraid to go back and check it. Okay? Get the problems right. It's not that bad. We have a way to check them, so do it. Now, next problem, number 10. What should we use as our zero pair? The best bet for using or to make a zero pair out of is going to be the set of 6's right here. Okay, we have a minus 6y and a plus 6y. As you can tell, those are going to cancel. Okay, and when we go to add this, that's going to be 3x plus 2x, which, as we know, is going to be 5x. Okay, and the 6y's are going to cancel. we are going to be left with 9 minus 4, which is going to be 5. We divide each side by 5, and we have x equaling 1. Okay, so 1. And then we just take this, and we're going to run it back around up here, and that's going to be 3 times 1 minus 6y equals 9. So 3 minus 6y equals 9. We minus 3 from both sides, and we got negative 6y equals 6. We divide each side by negative 6, and we're left with y equaling negative 1. Alright, so these aren't too terribly difficult. Just make sure that you find the zero pair, is essentially what it is all about. Now, time for word problems. 4 pencils and 2 pens cost $6. 6 pencils and 5 pens cost $12. Find the cost of a pencil, X, and the cost of a pen, Y. Alright, so we're not necessarily going to solve these, okay? But what we will do is we need to set up a system of equations, okay? All of our answer choices have systems of equations as them. That's what we need to do, okay? So 4 pencils and 2 pens, okay? So what we're going to do is we're going to make sure to label pencils. We need to make sure to underline this. Pencils are going to be X. Pens are Y. So what we have to do here is say, let's see, 4 pencils, which is going to be 4X. And then 2Y for 2 pens. Okay, and that needs to equal $6, as we've already established right here. Okay? Alright, now 6 pencils and 5 pens cost $12. So we're going to go 6 pencils, so 6x plus 5y equals 12. Alright, and that's not too bad. Now we have to see if any of these equations, any of these systems match what we're doing. Okay, so let's see. We've got 4x and 6x. That doesn't work. So that one has to go away. That one doesn't work. Okay, 4x plus 2y equals 18. Okay, all they did was they added the 6 and the 12, and that's not right. Okay, 4x plus 2y equals 6, and 6x plus 5y equals 12. That works. Okay, that is the correct answer. Now, on D, what they did wrong was they used the x and the y in the wrong places with the wrong coefficients. Alright, they switched them. Okay, they weren't paying attention to what the pencil is supposed to be and what the pen is supposed to be. Make sure that you are, though. Alright, now, Ellen is having a party and wants to make mixed nuts. Peanuts cost $2 per pound, and cashews cost $4.50 per pound. Okay, so we know that we're looking for 2P and 450C. So let's go ahead and make that into an equation of some sort. So we're going to go 2 times P plus 450 or 4.5 C, okay? And if we keep on reading, okay, we figure out how much she wants to spend. Ellen wishes to make 7 pounds of mixed nuts, but pay only $24. Okay, so that has to go like that. So we got $2 times the pounds of peanuts, $4.50 times the number of cashew pounds, and all that has to add up to $24. Okay, so next part is going to be P plus C equals, and then she wants 7 pounds worth, so P plus C must equal 7. So 2P plus 4.5C equals 24, and P plus C equals 7. Let's see which of our answer choices actually lines up with that. So we got 2P plus 4.5C equals 24, and P plus C equals 7. That lines up with what we're doing exactly, okay? But always a good idea to go back and double check the other answer choices, okay? Now, answer choice B has us paying $200 and $450 for peanuts and cashews. That's not happening, okay? That goes away. $2 for peanuts, $45 for cashews. Those are some expensive cashews still. I'm just going to get rid of that answer choice. And then over here on the end, we have 2P plus 4.5C equals 7. Okay? That wouldn't even be enough to get part of what we're trying to do here. So, that doesn't work. They got their cost and their weight mixed up. So, now moving on to number 13. On Monday, Logan had 2 hot dogs and a carton of milk, totaling $2.85. On Wednesday, he had 3 hot dogs and 2 cartons of milk, totaling $4.45. Which system of equations best represents the situation if H represents the cost of each hot dog and M represents the cost of each carton of milk? So, let's find out. So, 2 hot dogs and a carton of milk. So that's going to be 2H plus M needs to equal 285. Okay? And I got that simply by going 2 hot dogs plus a carton of milk. Okay? Totaling, that's equals 285. On Wednesday, he had 3 hot dogs, so 3 hot dogs, so that's going to be 3H. Okay, and 2 cartons of milk, so plus 2M, and that is 445. Now, the question is, do we have any of these answer choices that match up with what we decided on? So, we got 2H plus M equals 285. Okay, let's see. A works. Okay, or does it? It doesn't, okay, because we got our totals mixed up. Okay, B. We've got the right hot dog and milk, and it equals $2.85. We got 3 hot dogs, 2 milk, and $4.45. So B works on both levels. On C, we've got H plus M. At no point did it say just 1 hot dog and just 1 carton of milk. Okay, so that doesn't work. Okay, and then on the last one, it has us paying $285 for 2 hot dogs and 2 milks. Either those are really good hot dogs, or it's the wrong answer choice. Okay, so B. Now, last question. Okay, there are 411 people at a play. So let's see, 411 people. Admission was $1 for each adult and 75 cents for each child. So we've got A plus C equals 411. Okay, admission was $1 for each adult, so 1A plus 75C, 0.75C, if my pen will write correctly. Okay, and the totals were 395.75, so 395.75. Alright, now, here's the thing. Today, this actually bleeds into what we're doing tomorrow, okay? What we're going to do is we're actually going to multiply this bottom row by -1, okay? In order to get something that's going to cancel, okay? So, we've got our new equation is going to be A plus C. Our new system equals 411. Okay? And then that's going to give us negative A minus 0.75C equals negative 395.75. Okay, we go to add our two rows. The adults are going to cancel. And we've got 0.25 C equals, and then 411 minus 395 winds up giving us 1525. Okay, we divide each side by 0.25. And then whenever we go to do our division, we got C equals, and that should be 61. Alright, so we're going to do A plus, it's going to be 61, equals 411. We subtract 61 from both sides. And we got A equals, and then 41 minus 61 is going to be 350. Okay, so our final answer is going to be 350 adults. If I can get my pen to write correctly. Adults. Okay, and 61 children. I apologize, my pen is stopping. And there you go. So that concludes the notes for today.